All right, solutions to the Module 5 test review. A triangle with one obtuse angle is an obtuse triangle. If it has all 60-degree angles, then it has all of the angles are equal. It's equiangular. If it has no congruent sides, that is scalene, so that is F. One right angle makes it a right triangle. 3 congruent sides, equilateral. Your lats are your sides. Those are equal sides. That's A. 3 acute angles is an acute triangle. And 2 congruent sides is our isosceles triangle there. So speaking of isosceles triangles, in number 2, we are told that this triangle is isosceles and that the base of the triangle is segment AG. So since that's the base, that makes these two sides are congruent legs, and we know that the base angles are congruent to one another. We have to find the value of X, and then we'll use it to answer these questions. So I know that segment AM has the same length as MG, those are equal. So X plus 1.4 is equal to 2X plus 0.1. Subtract X, subtract that, and you end up with 1.3 for X. So the length of each leg, we'll want to plug it in. 1.3 plus the 1.4, and we get 2.7 for this leg. And if you plug 1.3 in there, you will get the same exact answer, which is good to double check that. But both the legs are 2.7 inches. And then for the base, we'll plug the 1.3 in there. So 3 times 1.3 is 3.9 minus the 4/10, and we'll get 3.5. All right, number 3, if you just look at the triangles, you do know that you have a pair of vertical angles. We've got angle, angle, and then the side, and we have angle, angle, and then the side. These triangles are congruent. However, the way they matched up the parts, they are not. SLP, starting at S, turning the corner at L, and finishing up at P, is not the same as starting at Z and finishing at P. We start with the unmarked angle in this triangle, and you're starting with the marked angle there. So because of that, we have to say no, they do not match. In this particular proof, we have 3 pieces of given information, and all of it happens right there in the first line. So we only get that free answer of given one time. Let's mark what we've been given. We have a pair of parallel sides. HT runs parallel to SF. So these are parallel to one another. Angle H and angle S are congruent, and segment HT is congruent to segment SF. So I can see I have a pair of congruent angles and a pair of congruent sides. I do need something else, and it does it for us, but what you should see is that there's a transversal that's crossing these 2 parallel lines, and these 2 angles right here are sitting in the same position. Those are corresponding angles, and those are the angles they named. So this one is angle F, and this one is angle HTO, but those are congruent because we have parallel lines that came first, and that's always going to result in congruent corresponding angles. And now that I have it marked, I can see that I have an angle, the side between them, and the other angle. So 2 angles and an included side is angle, side, angle. Okay, we have a paragraph proof. Down here, segment LE is going to bisect angle L. So here's LE, and this is angle L. So we know that those 2 things are going to be true. Let's see what they say. LE bisects L is given. Therefore, angle GLE, which is this one, is congruent to angle ULE, which is this angle, by the definition of, Well, because we knew what that word meant, we were able to mark those congruent. It is a bisector. It's specifically an angle bisector. Definition of angle bisector. Then they go on to say that LE is congruent to LE. It's congruent to itself by that's always the reflexive property. Anything is congruent to itself. And LE is perpendicular to GU was also given. Remember, that's what that symbol means. Well, how would I mark that in the picture? Well, I know that segments that are perpendicular, where LE meets GU, they form a right angle. That's literally what it means to be perpendicular. They intersect to make right angles. So LE being perpendicular is given, so angle GEL, which is this one, and angle UEL are right angles. That's what I marked. How did I know I could mark that? Because they were perpendicular. So I knew they were right angles by the definition of perpendicular. Because I knew what that word meant, I knew that they would form right angles. And now these triangles will be congruent by angle, side, angle. They're just going to take a step and say, well, I know that angle GEL is congruent to angle LEU. These are congruent angles. They're right angles, right? Because right angles are congruent to each other. So therefore, we can prove that the triangles are congruent, and the reason is angle included side angle, ASA. Angle, side, angle. All right, finding the missing values, I can see that I've got a pair of sides and a pair of angles, and I know those two triangles share those sides, so I know that these two triangles are congruent to one another, so all of the corresponding parts will be congruent. If this whole thing is 11, and these two pieces are equal, cut 11 in half, and each of these will be 5.5 and 5.5. And that's one of the things we're asked to find, the distance between points A and D. And then we need to find the measure of angle ADC. D is the vertex. ADC is this angle right there, and that one is congruent to that one. And since they make a linear pair and they're equal, the only way for that to happen is if they're both 90 degrees. In number 2, these triangles end up being congruent. That's the hypotenuse of this triangle. This is also a right angle. And then they share that side, and that's a leg. They're congruent by hypotenuse leg, so all the other parts are congruent. If A is 70 degrees, we're asked to find the measure of ACD. ACD is this angle here at the top of the triangle. And we know that these three angles have to add up to 180. So that would have to be 20. 70 plus 20 plus 90. And then they tell us that the distance between points A and D is 3. But remember, these triangles are congruent. So this piece has to be the same as that piece. And then we want to find the length of AB, that whole side. So add the two parts together, and we'll get 6 centimeters there. In number 3, I can see that all of these angles are congruent in this top triangle. Divide 180 by 3, and each of those are 60. And anytime all the angles are equal, so are all the sides. And they tell us specifically that the distance between A and E is 3.5. I can see that these triangles are congruent down here because I have a pair of angles, another pair of angles, and a shared side. They're congruent, so this also has to be 3.5. And that makes that whole side 7 if you add those together. All the sides of the triangle are congruent, so that's 7 and that's 7. And we're asked to find the length of DC. So when I come down here, I notice that these angles are also going to be 60 and 60. So this is also going to be an equilateral triangle, and if this side is 7, so are these sides. So DC is 7 centimeters, and then we have to find the measure of angle ADE, and ADE has D as its vertex. So we're looking for this angle right here. That's 60 and that's 90, so that has to be 30 in order for those to add up to 180. All right, in our proof, angle R is congruent to angle S. I know that because it was given. The other piece of given information is that side HR is congruent to side SC, and it was given. And then they go on to say that angle HUR, which is this angle, is congruent to EUS, which is that angle. How do we know that? Those are across from each other on the X, and we know that vertical angles are always going to be congruent to each other. And then look at the triangles that they've identified. HRU is that triangle right there. And ESU is this triangle right there. So how do I know they're congruent? Well, we have two angles marked, but not the side between them. Two angles and then a side. So angle, angle, and then the side. That's our congruency test. And then you can see that HU, H and U are the first and last letters. And sure enough, it's congruent to E and U, the first and last letters. So that is CP-CTC. All right, and then we just want to decide if we have enough information to see if these triangles are congruent. Side AB is running parallel to side CD. These are parallel to each other. And this is the transversal that cuts them. So the angle formed by the pink line and the transversal, I do know that those will be congruent. Those are alternate interior angles. They also tell us that side AD is congruent to side BC. So I've got a side and an angle, a side and an angle. But the only other thing I know, because there's nothing else that's given, is that they share that side. And if you look at those parts, you've got the angle and then the sides. That's an angle side-side situation. It's happening here as well. And that's not a valid test, so this one cannot be determined. In number 2, when I try to mark AC congruent to BD, I can't do it. So I'm going to do this. AC is my pink side, and it's part of this triangle. I'm going to draw that triangle up here separate. So it goes A, B, and C. And then BD is part of this triangle there, and I'll draw it here. And again, label those parts. So this is D, A, and B. And I'll label these triangles. So I can show that AC is congruent to BD. I can show that AD is congruent to BC, but now I'm out of given information. But these two triangles, the green and the pink triangle, share that bottom side. This is where they overlap. So segment AB has to be congruent to itself. So these triangles are going to be congruent by the side test. I just want to match up the parts. So if I do ADB, I'm walking the double and single mark side. So I would have to do it in this order over there, BCA. Number 3, I can see there's no given information, but I do know that these two vertical angles are going to be congruent. So angle, side, angle, angle, side, angle. The side is between the angles. So they did A, B, C. They went from the marked to the unmarked. So the marked to the unmarked, finishing at the vertical angle, it has to be EDC if we're matching parts up. And then we already said that that test is angle, side, angle. The side is included between the two angles. In number 4, I know that segment CD bisects this angle up here, so it cuts that angle into the two congruent parts. Segment AC is congruent to segment BC. No more given information, but we do know that the two triangles, we're looking at triangle ACD, right? That's the one. And it does indeed share a side with this one. So side CD is going to be congruent to itself. So these are congruent by side, angle, sides. The angle is included between the two sides in both triangles. And they did ACD, so we have to do BCD to walk it in the same order. Walk the single mark side and finish down the shared side. Okay, this one is similar to number 2, in that if I try to mark side AB congruent to side CD, I really can't do it because they overlap. It goes on to tell us that angle CDB, this angle, is congruent to that one. So this angle is an angle in the pink triangle, and this angle is an angle in the green triangle. We know that I'm just going to want to draw those triangles separately. So as I draw them separately, the thing I want to make 100% sure that I do is very carefully label these vertices. So in the pink triangle, D is down here, B is there, C is there, and we marked D. In the green triangle, A, D, and this point is the B, and we marked angle B down there. They told us that AB was congruent to CD, and then once again, those triangles share that side. Sometimes triangles might even share an angle, but these share a side. So they shared side DB. So they're congruent by the angle is included between the side in both cases. Let's just check it. ABD, so it would be ABD. Is it congruent to CDB? Well, we walked those sides in the same order. So this is yes, and the reason is side, angle, side. And then remember that in class today, we practiced a problem like these, where you had to find the missing information given the parallel lines and the triangles. And there will be a question like one of those on the test as well.